So I'm going to talk about this tool that we developed that is used to support researchers, but I think it can be adapted to support disaster recovery and response. And I guess the goal of my presentation is to make the case that this can be used for disaster recovery and response. I would also like to acknowledge the team that has actually worked on developing this tool. I think Kulkarni was the lead developer, and we had some great grad students who helped develop this tool. So here's the outline. I want to talk a little bit about disaster recovery response, the need for curated data and information within this, talk about the emergency management process. This is all from systems perspective and not from products perspective. And then I'll talk a little bit about the data albums, the design principles that we used in building this technology, this notion of information-seeking models, the notion of sense-making, maybe gloss over the architecture, and then show a couple of instances of data album technology, and then obviously the future work where we can actually adopt this or adapt it for disasters. So here's the definition of curation. Curation is the act of gathering and organizing and maintaining a collection of resources around a theme or a topic. You've seen a lot of people have created their careers curating information on web. But here the resources can be not just information, but it can actually be data. So from situational awareness perspective, what is the role of curated data? So if you look at the definition of situational awareness or the common operating picture, that was mentioned in the last talk, it's the need of getting the real-time tactical information in the hands of the warfighter. This comes from the military or the first responder. And this information has to be part of a seamless pipeline of data that spans the whole breadth of the mission. So there is this really interesting paper that talks about this reference architecture for situational awareness. And they talk about emergency functions fall under three basic categories. You have the strategic one that is looking at high level of coordination of emergency management. Then you have tactical that is actually looking at the immediate activities that you have to do in response to whatever disaster that's happened. And then there is whole operational aspect of management part of it. So the key for all the three is that there's a need for good quality and sufficient amount of timely, accurate and reliable information that's necessary at all three levels. So that's the key there. And the challenge that they list there is the types and the nature of information that's required. And most of the times they have too much information. They cannot figure out what is the right thing to use in a timely fashion. This is an interesting disaster response process that has been put forth by Carver in the 2007 paper, where they have three steps here. You have building the picture, understanding the picture, then you have the step of changing the picture using goal-oriented tasks. So again, the key needs, if you look at it for responding to emergencies they have here, is to absorb information quickly and make sense of its meaning, its relevance and reliability, and then you decide on the options and action. So what I want to focus on is I don't have a complete solution. I only have a little piece, but that can really help in this notion of building the picture and understanding the picture. So the key thing for challenges to this building the picture and understanding the picture is like how can you provide ways to gather information that's accurate and timely? And how can you provide a way to do information prioritization so that it can figure out what's useful and what's not? So can data and information curation help? And can it be automated so it can filter out noise? And how do you best present this information and data so that somebody who's using it can contextualize it really quickly? So if you think about it, this is basically a specialized search and information display problem. So I'm stepping back a little bit and talking about some information-seeking models. This is kind of the design principles we use for designing our tool and technology here. So there is a standard model where you go through this sequence of steps when you're searching for information. You identify the problem, that's your task. You articulate the information need, and then you formulate a query. and then you look at the result back. So the drawback here is that the assumption remains that the task remains the same, right? That doesn't change. You just tweak the query to get the results that you want. So there's also a different model for information seeking. There is a dynamic model that was put forth by Bates, which states that the user's needs evolve as they interact with the information that's being returned. So this is what they called information foraging. Like, as animals, go from one area to the other, finding food, they change their pattern. So this is pretty interesting because this whole notion of discovery of latent needs, that as you interact with information, it makes you modify your original goal. And that's it's very true because that's how we search. When we do Google search, that's how we do. We traverse to different paths that we not intended to originally. Sense-making is a behavior that's applied to intelligence analysts and other knowledge workers, and it's related to this whole process of information seeking. And there's a framework for sense-making that has been put forth, and it contains 3 stages. You have the first stage, which is a shoebox, where you gather all the relevant documents into a single collection. You have the notion of an evidence file, which is where the shoebox is curated even further down to a smaller set. And finally, you have the schema, where you take all the information and you build a conceptual model to link all the information that you've gathered within this evidence file. So that's kind of the process that they've conceptualized what an intelligence analyst uses. So if you look at the data search problem, most of the data search tools are built on a standard model. There is no notion of this discovery of latent needs. We don't allow in these data search systems a user to interact and traverse different paths while searching for data. So when we were building this tool, we actually asked the question, can we build a tool which adopts this dynamic model in its design that takes into account that sense-making framework for data search within earth science? So this is the data albums concept. It's basically a discovery and aggregation tool that auto-generates data albums. Data albums is nothing but a virtual collection of data, information, or the tools around an event or a theme to support science research. And the key element here is there is a way to curate this, and it is filtered using an ontology, an application ontology that does this automated curation for you. So it saves you some of the task of trying to find things that is distributed at many different places that you may or may not know. And the application ontology is used both for query expansion and relevancy ranking algorithm that we have in the service itself. So the concept here supports this notion of, it's supposed to mirror this shoebox evidence file approach. And the results are presented in the user interface in an interactive manner to support this whole notion of discovery of latent needs. And we use this dual coding theory where, if you present information in multiple modalities, it's much easier for an end user to understand what you're presenting there. So this is a standard 3-layer architecture for data albums. You have a data layer. There is an aggregation engine which invokes these different brokers that talk to different distributed resources. They pull in information from these resources, and that information is ranked based on relevancy for the topic that we are focusing on, and then aggregated into a database that we can then use. And there's a service layer on top that talks to an API, the client, for presentation. So the magic here is in this relevancy ranking algorithm. So this is the original algorithm that we developed. This is based on this O-rank paper that uses ontology as a basis of trying to figure out relevancy by looking at the metadata descriptions. So we use this as a really good starting point, but there are some major drawbacks with this approach, and we've been researching other approaches to improve the relevancy ranking performance. So this is great. I mean, this is absolutely new. This is a thing that I updated on Friday based on the results I've got. We've been working on, we experimented with 4 other algorithms. So O-rank is our current basis for our current algorithm. We looked at Wikipedia terms. We said, okay, what if we looked at all the terms in a Wikipedia article based on a particular topic or a theme? Can we extract those terms out in a bag of words approach, filter it against a domain glossary, like an AMS glossary, and then use those words for using TF-ID relevancy ranking? That's one approach. The other approach is, instead of building an ontology, we just use a bag of words. So we don't really care about relationships. We just want the set of terms that we can use for relevancy ranking against metadata. The last two methods, one is the latent semantic index. We use a dual set terms where we have both positive and negative terms to improve the ranking algorithm. And the last one is a metadata-based ranking. So the other approaches were top-down, where we're looking at a particular domain and then trying to build the ontology and the topic terms. This is, okay, let's look at the catalog and see the information that exists in the catalog in the metadata, and let's build from bottom up rather than top down and build rules based on that. So it's a different approach than the other ones. So what has happened is the two of these algorithms have actually shown really good results, and I'm really optimistic that these can be used in an operational sense now. So the two examples I want to show you for the data albums application. First one is a catalog of hurricane case studies at GHRC DAC. The other one that we are working on is for a severe weather case study for the NASA Marshall Sports Center. So this is a snapshot of the web page for the hurricane case study. So I'm showing you elements of the page. So at the top panel, you have analytics. So this is all the information that we've aggregated. Any measured parameter, we show analytics on it to allow you to search for events or look at things that are outliers. The information for searching is presented in many different ways. So this is showing you the sunburst view. So you can search on a particular year. The hurricane categories are color-coded, and the angle is showing the duration. So you're getting multiple information presented visually that you can select. You have your standard way, which is just a table, and then you have another bubble view that you can see where they're grouped together based on categories. So once a user selects a particular event, then the aggregation takes place. So this is showing the data album for Hurricane Sandy. It pulls in the track for the hurricane with MODIS overlay. It goes and grabs information from Wikipedia. It pulls in the YouTube videos related to Sandy. And of course, the key thing is the data that you're after. So here's the curated data based on the hurricane relevancy algorithm. And it's presented, you can filter it down by keywords or platforms. And it also provides you with a relevancy threshold. So if you think it's providing you too much data, then you can increase the relevancy threshold to filter down, or you can decrease it if you're getting too less of data sets. And ultimately, the final thing that you actually need is the list of data sets for that particular time that are relevant for that studying for that event. So you get this link that you can download and write into a script to access the data. This is the example for the severe weather case study generator. So we are searching for events based on storm reports for hail, wind, and tornado damage. So it shows you the trend over a few years, and you can select a specific year and you can drill down for months for that year, or you can drill down to a specific day within a month. So it allows you to kind of look at the statistics and identify the case that you want to use. And the one that we selected is the April 27th, 2011, which was a severe tornado that occurred in South. So it's aggregated all the convective outlooks, the watches, the mesoscale discussions, the severe weather outlooks. You have, again, the data collections, the granules, the tweets, the video, and images of damage from the flicker. So this is doing this automated collection for you. So how can we adapt this technology? So right now, if you look at the technology, it's doing retrospective aggregation, right? It's basically all the things that have happened. For disaster response, you may need real-time aggregation. So that would require, configuring some of these brokers to the right distributed data and information resources that can meet the time requirements that is needed. Another thing that's required is it needs a trigger. So it needs an event a monitoring trigger. So it can basically monitor a news report or any disaster event news feed to spawn this aggregation tool. I had this that we needed to improve our relevancy ranking, but I think with the new results that I've seen, I think we are in pretty good shape on that part. The last bit is, of course, the display itself needs customization per application that we found. Each application requires their information presented in their own way. One other thing that we could do is provide a common API to have access to the data albums collection for a particular event. So here's my summary. I think this technology can be useful within any system to support disaster recovery, and this can address that piece that I was talking about, that building and understanding the picture part. So here's the link at the bottom if you wanted to go try out the data albums Hurricane page. Thank you.